Howdy. Actually, I forgot in my last video where I've been talking about radio sulfur, atmospheric sulfur, to show the equinox aurora time lapse I took. And yeah, I have been talking also about the auroras and about how I think some of the copper occurrences we find nowadays on Earth are originated from above, possibly by ground-touching auroras. So now let's just have a look at the equinox auroras, which I took. At the equinox, we had a rather strong solar storm back then. We will first look at it in original speed and without any enhancements. Now let's just have a look at this. There are some probably satellites, maybe even some shooting stars. I'm not too sure about them. And I also have some pictures of these, but it again would be a very long video to take a look at all of these pictures and stuff. So let's just have a look at this time lapse. Then we make some enhancements to this, increase the brightness a little bit, maybe slow it down, and then we will have a look at cold plasma as well, because we are looking at hot plasma at this point. The geomagnetic activity we had at the night or in the night of the equinox, which is just a few weeks back. And I think we can also here in this time lapse see some of the flickering aurora phenomena, which I have been talking maybe more than a year ago or something. And it wasn't a camera glitch, because there is actually something like flickering auroras. And I don't remember if I made a video about that. If anyone knows if I did or if I haven't, I might make a video about flickering auroras. Because I didn't know about that. I only noticed the flickering in one of my time lapses. Now you can see it's getting bright and we still have the auroras a little bit visible. We are also getting the cold plasma, i.e. the clouds. So now it's obviously getting too bright for a night time lapse video. Now we go to the beginning and make some little enhancements to this. Maybe we just go with this. Maybe, nah, still a bit more. Let's increase the color density a bit and still the brightness a little bit. Maybe that's good like this. And we look at the whole thing now once again. With half speed. That's already an interesting phenomenon, this green band. And due to the enhancements, it looks a little bit strange sometimes, the colors, but we can see much more. And even though this is with white screen, or how to put it, with a wide adjustment on the camera, it didn't catch nearly all the stuff that was visible. Now I just noticed that I wanted to show you something. Now let's slow it down even more. And take a look at this area here. This one. Yeah, that was an interesting phenomenon. Probably some clouds that just went by and it made this kind of an interesting pattern. And I don't know if animals, like nocturnal animals, like cats, they could probably see the auroras much better than we do with bare eyes. And this was somewhat the first wave, and it seems now it's a little bit dying down, but it will come back. And it seems that the second wave was much stronger. And as you can see here, the sky is still a little bit colored. It's not black, so to say. There's still some auroral activity going on. It's just very faint, which you only can see when you increase a little bit the colors or the brightness. Yeah, now it seems to pick up a little bit again. Yeah, in these weird times, it's probably not a bad thing to present and be able to present something beautiful and have a moment of zen, so to say. Even though most people aren't really aware of the danger of the auroras. Ancient people, they were afraid of the auroras. The ancient people in Finland, they knew to, or they used to say that if you see the auroras, put on a hat. Don't speak loudly, don't sing, don't whistle, don't make the auroras angry, because they could come down and kill you. The ancient Aborigines, they were afraid of the auroras because for them, the auroras were a river of fire in the sky. In other words, they knew that the auroras are hot. And I somehow highly doubt that they had any satellites or any ladder in order for them to climb up into the sky and check it out. So the only way for them to know that the auroras are hot 2 to 3,000 degrees Celsius was quite likely that the auroras came down to them. And as the saying goes, history tends to repeat itself. And Earth's magnetosphere or magnetic field is weakening. Much less solar activity creates much stronger geomagnetic activity. Yeah, because the magnetosphere gets weaker. It's after all very simple. So actually, now just put pause here and I want to show you this, how clouds form, or how do clouds form? Clouds form from the condensation of water vapor. Water warmed by the sun rises, evaporation cools, and changes to water droplets, condensation. This is what you get taught in school. And then the clouds, they smash into a mountain and it starts to rain and the river starts to flow and the whole cycle starts once again. As you can probably imagine, I could talk hours and hours and hours about this. But now let's just look at the time lapse I took today, which I call standing plasma patches, because in my opinion, clouds are plasma. And one could argue that, yeah, these are water droplets because the sun is shining, they rose up and stuff like this. But we have all these lines here, and cloud nuclei, i.e. some dust particle, attracts water molecules in the air by the electrostatic force. In other words, there's a whole lot of electricity in the sky, which is most easiest witnessed, understood by a lightning strike that comes out of a thundercloud. But as I have been showing and explaining in many videos, all these repetitive patterns here, we can see smaller waves within the bigger waves, we can see frequency. So now let's just have a look at this time lapse. Maybe we have to slow down this a little bit. Let's watch it in half of the speed. Because you will notice there is no water vapor on this side. It just all of a sudden starts to emerge. And in a way, you could say that the clouds don't really move. I.e., I think there's maybe something, some energy, let's call it pillar, that rises up from the earth, maybe some deep below from the earth, up in the sky, where the air gets ionized and plasma starts to form. And in all of these clouds, you can see somewhat the same pattern, the same frequency pattern. And I call it frequency because it seems to be a wave that is traveling somewhat through a certain layer of the atmosphere. And it's very annoying because at the second I touch the mouse, there's this little thing popping up. But if you look, for example, at this edge, it stays approximately at the same place, at least for a while. And you can see these little areas, let's say this one and this one, yeah, they are about the same size. And you can see all these little things here. And I learned from Andy Hall that this pattern is called tessellation, like cellular structures. And if you look closely, it doesn't really seem that the clouds are really moving. There's just the air. The air is moving, and as it goes through certain areas, it gets, so to say, ionized, and the cloud forms in this area. But as the air moves on, the ionization stops and the cloud disappears. And if you look closer, you can see these really, really small wave patterns within these bigger waves, which is yet another indication of this whole phenomena being electric in nature, because electromagnetism is scalable. Now we have a very nice example here on the right side. It seems to be even spinning. Yeah. Ain't that amazing? And now it's gone. Let's just go to the beginning and increase a little bit the contrast. And put the brightness a little bit down. And this little streak you see on the left side, or there are actually two streaks. Let me show you. This one here and this one here. I think that's a lens flare from the sun. Might be some really high up in the sky clouds as well, but I think it's a lens flare. So don't mind this feature here in this picture. Today there has been an amazing sky. As if the universe tried to get me in a better mood. Yeah. Maybe I took a picture or two, I don't know. But I took this time lapse over several hours, and to me it seemed to turn out rather nicely. Even though that it didn't seem to really pick up the colors because there has been some rather colorful clouds today as well. Not only were they very nicely shaped, very electric universally shaped, but they were also colorful. And I'm still trying to figure out of how sometimes the clouds are colorful and sometimes not. What's the secret of that mechanism? Haven't figured out yet. Maybe I would never figure it out. But it's still on the bucket list. Somehow to me, this time lapse alone, in a way, debunks the somewhat mainstream explanation of how clouds form and stuff like this, because this doesn't really look like what they are trying to explain us. Especially when you can make, if you are really lucky, you can make the exact same time lapse of the same clouds in winter as well, when we have freezing temperatures and there's no water evaporating anywhere. And some of those elongated clouds, you can see actually how they spin. or at least appear to spin. I wouldn't be surprised if they would spin after all. And it's also like if people would see more time-lapse videos of clouds, not only pictures, if they actually could see how they move, they probably would understand by themselves that the mainstream or common theory about cloud formation is at least partially totally wrong. Because where those clouds are floating around, it is quite likely below 0 degrees already. And yet they're still forming. Out of the blue, literally. A while ago, I came to the conclusion that I think that weather is very often steered from below and not from above. In other words, there's energy traveling through Earth's mantle or crust, which is reflecting in the sky in the form of high or low pressure systems. Also, does the sun has a huge influence on weather? Things like solar flares, CMEs and stuff like this, coronal hole streams, whatever. The constituency of the solar wind. Let's see, do we have still? No, I think it's over. Let's just increase a little bit still the contrast. Maybe saturation too. Let's see what happens. Then we can look at this cloud, how it spins, or at least seems to spin. And that might be the end of this video, as this cloud is disappearing. Yes, I think that's it for now. A little bit of clouds with some very interesting features as well here in the middle. But anyway, thank you. Bye.